Okay, so for today's problem, we'll do number 12.67. This is on page 415, so again, from section 12.3. Question says, in some states, law requires drivers to turn on their headlights when driving in the rain. Officer believes that less than 1/4 of all drivers follow this rule. As a test, he randomly samples 200 cars and counts how many have their headlights turned on, finds the number to be 41. Is there enough evidence at the 10% significance level to support his belief? Okay, so, I have my book here. So we'll look at the question. So what is the officer checking? He wants to know whether the proportion is less than 25%. Okay, so kind of sneak preview. That implies that our hypothesized proportion is 0.25. Okay, so we're going to keep that in mind as we work through this problem. First off, again, because it's asking for a hypothesis test, we'll go through the 6 steps. First step, as usual, is to check the necessary conditions. And the first condition is always the standby, that we have an unbiased sample. Again, we'll have to assume that based on faith. Next step, our next sub-condition, is to look at those necessary conditions that we need for when we do a hypothesis test. And remember, those are based on the expected number of successes and expected number of subjects that don't meet the criteria. So first off, looking at the expected number of subjects that do meet the criteria, that would be P tilde, the proportion that we believe of all subjects that meet the criteria, times the number of individuals in our sample. So here we said P tilde is 0.25, and the question says that there are officers looking at 200 cars, so N is 200, and that number comes out to 50, which is greater than 5, so that checks off okay. Our other sub-condition here is that the expected number of subjects in the sample that do not meet the criteria is also greater than 5. Well, to find that, we find 1 minus P tilde, which will give us the expected proportion that, the hypothesized proportion that don't meet the criteria, times the sample size again. So it's going to be 1 minus 0.25 times 200, and that will be 150, which of course is greater than 5. So it looks like our necessary conditions hold. Okay, and step 2 then will be to determine our hypotheses. First off, the null hypothesis. Remember, the null hypothesis is always the parameter equal to some number. Here the parameter we're estimating is the population proportion equal to, and the number one here is the number we're testing against. If you recall, the question says that officer wants to check whether that's 1/4 of all drivers, so that proportion is 25% or 0.25. The alternative, remember, we can just rewrite the parameter P, bring down the value 0.25, and think about what's that operator in between. And if remember the question says officer wants to test whether it's less than 1/4, this implies that we have a less than sign there. Okay, and so the important things to take away from this step, first off, we already determined this already, but the hypothesized proportion is 0.25, and then we have a one-tailed test, this time to the left. Remember the lecture notes from today's class, from Tuesday's class, were that the one-tailed test to the right. Okay. So next step will be to look at the rejection region. So we need 2 things for our rejection region. First off is the type of test, and the second thing we need to worry about is our significance level. Okay, so I'm going to draw a picture of this. Again, we're looking at these separate columns, the Z distribution, standard normal distribution, which you can write in terms of Z statistic, starting at 0. The first thing, type of test, so you have a one-tailed test with a less than sign. So that means my rejection region is going to be in the left part of the distribution. So over here to the left, it's going to be my critical value right here. Significance level, I didn't state it, but we know that the significance level, the question asks for a 10%. So that means we're going to put 10% probability here in this tail. Okay, so what's this critical value? Corresponds to a Z statistic. Remember the subscript here is going to be left tail probability based on the table that we have here. So it's going to be 0.10. If you look at our table, Z of 0.10 is negative 1.28. Therefore, our rejection region, is our test stat, is less than negative 1.28. Okay, so that's our rejection region. The next step is to look at the test statistic. And so the test statistic, again, this will be a formula I provide for the exam, but Z equals P hat minus P tilde all over square root of P tilde times 1 minus P tilde all over N. So just a matter of plugging the values here. P hat and sample proportion, actually we had not found that yet. P hat is going to be the number of subjects that meet the criteria. Here we see the number of subjects that did have their lights on, or 41, divided by the total number of subjects in the sample, and the officer looked at 200 cars, and so that's going to be 0.2050. So now we'll find our test statistic. Z, remember, equals, or plug in these values, the sample proportion we just found is 0.2050 minus the hypothesized value, which we said is 0.2500, divided by square root of hypothesized value 0.25 times 1 minus 0.25 all over 200. And then again, when you calculate this, remember, do every calculation to the fourth decimal point. So do this, 0.25 times 0.75 to round to the fourth, divided by 200, round to the fourth, etc. And when you go through all the steps, it comes out to negative 1.50. So that's our test statistic. Then what we do is look at that test statistic value compared to the rejection region. We said earlier our rejection region was when the test statistic is less than negative 1.28. When negative 1.5 is less than negative 1.28. Therefore, test stat is in the rejection region. Therefore, we're going to reject the null hypothesis. Okay. So we have our thumbs up, thumbs down vote on the null. Our last step is to look at the p-value. I'm not going to go through the summary step here. So our p-value, again, that should be step 5 actually. P-value, two things we need to know to find it is the value of our test statistic and the type of test that we have. So let's draw a picture and try to illustrate this again. Z statistic, staring normal, staring at 0. Test value we found is negative 1.5, so I'll write negative 1.50 here. So that's where we plug in our test statistic value. Now we have to worry about the test type. We said earlier it's a one-tailed test to the left. So I know my p-value then is going to be the probability I'll be less than negative 1.5. Write this in the equation. P-value equals probability that z is less than negative 1.5. And we're lucky here in the sense that this is a left-tail probability, and so we can go directly to the table. And if you look up z of 1.5 in the table, you find that value is 0.0668. And so that wraps up question 12.67.